So as I mentioned before, a z-score tells you the distance along the x-axis on a normal distribution between the mean and some value counted in standard deviation units. So what I'm going to draw here is just going to be a generic normal distribution with the mean and then, some means and standard deviations units here. So for example, if you jump out one standard deviation, you get to the mean plus one standard deviation. This means that we are one standard deviation away from the mean in a positive direction, so we would have a z-score of 1 right here. Let's say we go from the mean and we go out 2 standard deviations in a negative direction. So here we're going out to 1 standard deviation here, minus 1 standard deviation here, and this is bringing us to the mean minus 2 standard deviations. This means that we would have a z-score of 2. So in other words, z-scores are counting out from the mean in standard deviation units. Let's say we go out one more, so we go another 2 standard deviations in this direction. So here we're at the mean plus 3 standard deviations. Here we'd have a z-score of 3. So obviously here I haven't filled out all of the values that you could have along the x-axis. I've just pointed out a couple of the possibilities. And the key, again, is that you're counting away from the mean in standard deviations. So, I should say negative 2, sorry. So when you're at negative 2 standard deviations away from the mean, so you've gone 1 standard deviation and then 2 standard deviations in a negative direction, you're at z is equal to negative 2. You go 1 standard deviation away from the mean in a positive direction, you're at z is equal to 1. And if you go out 3 standard deviations from the mean in a positive direction, so 1, 2, 3, you're at z is equal to 3. We can also plot these same z-scores with our example normal distribution, where we're looking at the number of thefts and our standard deviation is equal to 15. So here we had 1, 2, and 3 standard deviations. We're at 80, 95, and 110. Going in a negative direction at 1, 2, and 3 standard deviations, we were at 50, 35, and 20. So here, let's say we want to look at negative 2 standard deviations away from the mean. So here's a jump of 15 in this direction, another jump of 15 in this direction to bring us to negative 2 standard deviations. Our z-score for 35 thefts here would be negative 2. And so it corresponds to the exact same spot as it did here, except instead of counting in standard deviations, we're counting in the numbers that correspond to standard deviations. So a 1 standard deviation jump in a negative direction is 15 things being stolen. Another standard deviation jump in the negative direction is another 15 things being stolen, bringing us to 35. So we'd say we have a z-score of negative 2 for 35 items in this example distribution, where this is number of thefts. And this is probability. So we can also plot these other z-scores here. So let's say we go out 1 standard deviation, and we're at 80 units now. The z-score for 80 units is going to be equal to 1, because we're 1 standard deviation away from the mean going in a positive direction. Let's say we go out 3 standard deviations from the mean, so we're counting in units of 15, since 15 is our standard deviation, just to have this as a reminder here. So we're going out 3 jumps of 15 away from the mean to get to 110 here. And we'd say that we have a z-score of 3 for 110 thefts, because 110 thefts is 3 standard deviations away from the mean, so 3 jumps of 15 away from the mean. You can also calculate z-scores for values that are not exactly 1, 2, or 3 standard deviations away from the mean. And to do that, you would use something called a z-score formula. And specifically, the z-score formula looks like this. Z is equal to x minus mu over sigma, where x is some value that you're interested in. Mu is the mean of the normal distribution, and sigma is the standard deviation of the normal distribution. So as an example, we could find a z-score for 60 thefts. Specifically, I'm going to draw this, like I've said, specifically like 1,000 times today. I don't know where that's coming from. But we're going to draw this out. And what we're looking for here is the z-score for 60 thefts. So at 60 thefts, we want to know how many standard deviations are we away from the mean. And to find the z-score for 60 thefts, we would plug everything we have into this formula. So for 60 thefts, we're looking for a z-score. The first thing we're going to plug in is our value of interest. And in this case, our value of interest is going to be 60. We're also going to plug in the mean for our normal distribution. Here, our mean is equal to 65. And then we're going to divide everything by the standard deviation for our normal distribution, which in this case is 15. So from here, you can do this math. You get -5 over 15, and that gives you -0.33. So the z-score for 60 thefts would be -0.33. So we'd say z equals -0.33. And what this tells you is that 60 thefts is 0.33 standard deviations away from the mean, moving in a negative direction. We'll also look at an example that's on the other side of the mean. So let's look at the z-score for 100 thefts. And we want to know how many standard deviations away from the mean 100 thefts would be. So for 100 thefts, we're going to use the same formula. And the only difference is that now instead of plugging in 60 for our value of interest, x here, we're going to plug in 100. So we have 100 for x, our value of interest. Our mean is the same because we're working with the same normal distribution, so our mean is going to be 65. And our standard deviation is going to be 15. So mean and standard deviation, same each time. Also, as a note here, for any problem like this, I'll be giving you the mean and standard deviation. Normal distributions are based off of some very complicated formulas, and it's far beyond the scope of this class to calculate mean and standard deviation. And in fact, in my entire career as a researcher, I have never calculated the mean and standard deviation for a normal distribution by hand. So not really worth knowing, something that I'll just give you, and you can understand it to describe where along the number line your mean falls, and then how narrow or tall your, how narrow or flat your normal distribution is. Okay, so with that side note, we're now going to do some number crunching here and calculate the z-score for 100 thefts. So we do 100 minus 65 over 15, gives us 35 over 15, and that comes out to 2.33 as the z-score. So we'd say that z is equal to 2.33, and that means that 100 thefts is 2.33 standard deviations away from the mean, moving in a positive direction.